In this section, we're going to be talking about one specific kind of function, linear functions. Some functions are linear functions and some aren't. And a lot of what we talk about here in this section may be familiar to you. We're going to be talking about things like slopes and y-intercepts and linear equations. And these are things that I hope you've already seen before somewhere. They're all covered back in chapter 3 of our book. And the only thing that's really new about what we're doing here, we're kind of reviewing and putting all that together, but the only thing that's really new about it is we're talking about it in terms of functions. So instead of y equals something involving x, we're going to eventually write it as f of x equals something involving x. So let me start off with an example. Let's say you walk into a pizza place and you ask, how much for a pizza? And the guy says, well, that depends on how many toppings you want on it. The price of the pizza depends on the number of toppings. Or to put it a little more mathematically, the price is a function of the number of toppings. And then he shows you this list here. So for a pizza with one topping, the price is $8. Two toppings, $8.75. Three toppings, $9.50. Four toppings, $10.25. Five toppings, $11. So that counts as a function. Price is a function of number of toppings. And if we plot points, if we draw a graph, and for each pair of numbers with the number of toppings and the price, we put a dot on the graph, turns out that those dots all line up in a straight line. We could draw a line that goes through all of those dots, and we could write an equation. P of x equals 0.75 times x plus 7.25. So if you took that equation and put in place of x any particular number of toppings, 1 or 2 or 3 or 4 or 5, this formula would give you the price. And the fact that the points line up in a straight line makes this a linear function. And notice that with a linear function, the value of the function always goes up by the same amount. So in this example, each time the number of toppings goes up by 1, the price goes up by 75 cents. And you can see that in the formula with the 0.75 times x. So if x gets 1 bigger, P of x is going to get 0.75 bigger than it used to be. So this is an example of a linear function. Now let's talk about what linear functions are in general. A linear function is a function of the form f of x equals mx plus b. That is, your function of x is made up of an x term, some number times x, plus a constant term, just some number. So examples of functions like this would include f of x equals 7x plus 12. F of x equals 2/3 x minus 5. F of x equals negative 2x plus 0. Or P of x equals 0.75x plus 7.25. So the m and the b here can stand for any particular numbers. Any number times x plus any other number, you've got yourself a linear function. And the graph of any function like this, any linear function, is going to be a straight line. The slope of that line is m, and the y-intercept is b. In other words, you get a line where the slope of the line is the coefficient on x, and then the line crosses the y-axis at the point 0, b, whatever number b is. For example, take the function f of x equals negative 1/2 x plus 3. And you may be used to seeing y equals mx plus b. It's the same thing. We're just writing f of x in place of y. So f of x equals negative 1/2 x plus 3. The slope of this line is negative 1/2. And that tells you what direction the line is going. That tells you that if you start at one point on the line and go down one space and over two spaces, you get to another point on the line. Slope is sometimes referred to as rise over run. So the number on top is the rise, how far you go vertically, and the number on the bottom is the run, how far you go horizontally. So if we rise -1 and run 2, that means we're going down one space and over two spaces to get from one point to another along that line. And the y-intercept is 3. That tells us that this line crosses the y-axis right there at the point where y is 3. The coordinates of that point would be 0, 3. Another example, f of x equals x minus 4. The slope of this line would be 1. Just x by itself you can think of as 1 times x. And the y, because the slope is 1, and you can think of that as just 1 over 1, so rise over run would be 1 over 1. Go up one space and over one space, and you get to another point on the line. And the y-intercept is -4. It says x minus 4, but if you want to think of that as x plus something, that something would be the number -4. So that tells us that where the line crosses the y-axis is down here at -4, at the point 0, -4. Let's try another example. What are the slope and the y-intercept of f of x equals -1/3 x plus 2? So first of all, what's the slope? Louder, I can't hear you. Did you say -1/3? Good. And the y-intercept? 2, or the point 0, 2. I would accept either one. When I ask you what's the y-intercept, you can either just give me the number, so that'll be the y coordinate, or you can give me the x and y coordinates both of the point on the y-axis. So the x coordinate is always going to be 0 for a point on the y-axis, which is why we really only care about the y coordinate that goes with 0. And what does the graph look like? Well, knowing these two things makes it easy to draw the graph. I can start at the y-intercept, so find that point on the y-axis, and then having a slope of -1/3, down 1 and over 3. -1 over 3 means from here, if I go down one space and over 3 spaces, that would give me another point on the line. Now I know what direction the line is going, and I can just draw in the line that goes through those 2 points. Now let's go the other direction from the slope and the y-intercept to an equation. Use function notation to write an equation for the line with slope -2/3 and y-intercept 0, 10. So we just have to write f of x equals mx plus b, but in place of the letter m, we have to put the number that we're using for the slope. And in place of the letter b, we have to put the number for the y-intercept, the y-coordinate of that point. So we would write f of x equals -2/3 x plus 10. Let's try another one like this. Write an equation for the line with slope 1 and y-intercept 0, -5/2. And when it says use function notation, that means instead of writing y equals mx plus b, we're going to write it as f of x equals mx plus b. So If we're putting 1 in for m and negative 5/2 for b, and it's f of x equals x minus 5/2. So that would be 1 times x plus the number negative 5/2. Now that only works when you have the slope and the y-intercept. The point that you have does have to be the y-intercept. It can't just be any old point. It has to be the y-intercept, which means its x-coordinate has to be 0. But what if the point that you know isn't the y-intercept, it's some other point on the line? In that case, if you want to write an equation for the line, you can use point-slope form. Now I'm going to end this video here, seems like a good stopping place, and come back in the next video and we'll look at how this works, point-slope form.